Right, good day to all my wonderful online viewers. Just to remind you, if this is your first time of watching this YouTube channel and you have not subscribed, it won't cost you money. Just press the subscribe button, strike the bell also for notification of other videos, and other videos when they come on board you'll be able to see them. Thank you for viewing. Let's continue watching this video. To chemistry class. We are going to be doing some practicals, and I will be showing you some of the reagents that will be involved in the practical. Endeavor you listen quite well, and after this time you may not be seeing my face, but you'll be seeing my hands and the reagents as I'll be displaying them to you. So let's move on. We have this as spatula, we have this as iron 2 chloride. This is the crystal. Inside this we shall be testing for iron 2. We shall also be testing for chloride ion. We will test for iron 2 ion as well as chloride ion. Don't forget, put that on your mind. When you dissolve iron 2 chloride in water, it's going to give you a solution that you are seeing inside this beaker. And this is spatula. So I could use it to take part of it up for you to see. I have dissolved the iron 2 chloride here. Now, one of the 8 reagents to test, or some of the reagents you will use to test for iron 2 ion are: number 1, sodium hydroxide. And when you look at this place, you will see sodium hydroxide, and also potassium hexacyanoferrate 3. This is potassium hexacyanoferrate 3. I have dissolved it in water, but it comes in crystalline form. This is the crystal of potassium hexacyanoferrate 3, looking reddish. That is the crystal of potassium hexacyanoferrate 3. This potassium hexacyanoferrate 3 can be used to confirm the presence of iron 2. When you put it into a solution that contains iron 2 ion, you will get dark blue coloration. That will confirm the presence of iron 2. Look at this. If you want to test for chloride ion, when you dissolve the iron 2 chloride in water, just get a little quantity of the solution. The first thing you will add is HNO3, dilute HNO3, dilute HNO3. When you add dilute HNO3, the observation will be no visible reaction. Now, when you follow by adding aqueous solution of AgNO3, immediately you add AgNO3, there will be white precipitate. I want to take it other way around. When you add AgNO3 to a solution that contains chlorine, there will be white precipitate. When you add dilute HNO3, the precipitate will not dissolve. And when the precipitate is not dissolved, you said chloride ion is present. So to confirm that chlorine is actually present, you will have to add dilute ammonia solution. When you add dilute ammonia solution, the white precipitate will dissolve. That will confirm the presence of chloride ion. You have to watch this video again. Now, the real practical, when you will see the color actually change, will be done in a nutshell. Thank you for viewing. We are going to quickly do this video and it's a video on how you can test for chloride ion, that is Cl minus. All you need do is to get a compound that contains chlorine. It could be sodium chloride, it could be iron 2 chloride. Please bear in mind, any compound containing chlorine would give positive test to this kind of test I am about to show you here. So, this is a solution. Inside this test tube in my hand is a solution that contains chloride ion. And let us see the test and the responses to the test it will give. Mind you, you are going to tabulate test, observation, and inference. I have told you, let's even assume I did not tell you the content of this. Now with the observation, you will be able to know what I'm talking about. Some of the reagents I will be applying here. Number one, I'll be applying HNO3. HNO3, I mean dilute triazole nitrate 5 acid. Dilute hydrogen triazole nitrate 5. I'll be putting it first. Then I will ask you, what can you observe? Now let's go. Let me pick it from here. This is dilute hydrogen triazole nitrate 5. Few drops of it I pour. What did you see? Have you responded? There is no color change. That's good. Clap for that guy. There is no color change. Okay, instead of there is no color change, you will have said there is no visible reaction. Now, I will move further to this same solution I have here. I will add silver triazole nitrate 5. Let me pick it. This is silver triazole nitrate 5. And I'm going to pour some drops that you see. Oh wow, what can you see here? There is white precipitate. That is the observation. You can see the lower part is clear and the upper part is having white precipitate. View it very well. It's having white precipitate. Now to this white precipitate, it shows that CO32 minus is present. It also shows that Cl minus is present. Now let me do something. Let me add dilute ammonia or ammonia solution. Now I have added ammonia solution. It has started reacting. You will see that the precipitate is dissolving. Yes, the clear solution you can see under. Similar solution have started happening from the top. The precipitate is dissolving. As the reagent, that is the ammonia solution I pour, is moving down, it will continue to dissolve until it will finish dissolving all the precipitate. This confirms the presence of chloride ion. So, in summary, chlorine is present. That is, Cl from any compound of Cl is present. So there is Cl minus, chlorine ion is confirmed. The reason because the white precipitate is dissolved when ammonia solution was added. Hope you get that. If you don't understand it, watch the video again.
That is how you can test for ammonia solution, and that's how you can test for chloride ion in any compound that is given. Thank you. I just want to do the opposite of what I did earlier. What I did earlier was to add dilute HNO3, which brought a result that you and I was able to see that there was no visible reaction. Now, I want to start by adding AgNO3. This is a solution that contains chloride ion. Let me add AgNO3 to it and say wonderful thing. White precipitate directly shows up white precipitate. Now let me add dilute HNO3. When I added dilute HNO3, the precipitate did not dissolve. It remained. The precipitate did not dissolve. It shows that chloride ion is present. Can you remember the first thing I did? I added AgNO3. There was white precipitate. I added HNO3. The precipitate did not dissolve. But earlier than now, I added HNO3, no visible reaction. I added AgNO3, there was white precipitate. Take note of the difference between the two. Now let's go on to add dilute ammonia or ammonia solution to it. Now ammonia solution has been added. You can see a clear solution. It dissolves. And because it's dissolved, you can now say Cl- is confirmed. That is, chloride ion is confirmed. Please, whatever way it comes, know what you are doing and do it well. Alright, here I come again. I want to describe how you can test for iron 2 ion. Iron 2 ion is very sensitive and it can be easily oxidized. And the color is green, as in iron 2 is greenish in color. So the first reagent we shall be applying is sodium hydroxide. Sodium hydroxide, this is sodium hydroxide. As I put it inside this, we have a greenish coloration, a greenish precipitate, which does not dissolve in excess sodium hydroxide. It does not dissolve in excess sodium hydroxide. Now, another portion of the compound, of the solution of the compound, we want to confirm now the presence of iron 2. You should know that when you leave the greenish solution, for some time it will turn reddish brown. That is, oxidation will have taken place. Iron 2 will have become iron 3. So let's leave this one for a few minutes now as we go to confirm with another sample. This is potassium hexacyanoferrate solution. It is being used to confirm iron 3, and it will turn this solution dark blue. Now observe, though I've told you, but try to observe it. Now it has turned dark blue. This confirms the presence of Fe2 plus. This is dark blue precipitate, confirming the presence of Fe2 plus. So please, you have to watch this video over and over again to get the details from me. Thank you for viewing.